Okay, everybody, hello. We're doing episode number 9 of this project, and we're going to go and continue implementing the algorithm, which is here, and we're doing this first loop here where we're going to try to complete this loop. And there's a couple of things that I left off from last time, and I want to refine the code that we've written so far. So let me first adjust this. I'm going to work on that a little bit more, but in our code, we're looping through an array of letters. And at the same time that we're looping through, we need to keep count of which letter we're on, what number letter we're on. And to solve that, to get a loop counter, we can just make a counter right here, like what we've done, where we've initialized some variable and we increment it. And here, when we're making the String.Index, which we're using to index into a string, that was the whole big deal from yesterday. We're referencing it. But it turns out that Swift has a feature that lets us iterate over an array with an index, and it's called enumerated. And what it does is it lets you specify an index alongside the value that you're iterating on, provided that you call the enumerated method. And the enumerated method is a part of an array. So that's a small thing that we can do to make it a little nicer. So I'm gonna make this IC. I'll get rid of this line here. And I forgot to put this into Vim mode. That was the big thing from yesterday for me. Vim mode, everybody. Now I'm going to go and delete this line, and I'll also delete this. And what happens is we can run this test, and let's run all of them. Hang on for a second. Tuple pattern cannot match values of non-tuple type letter. I forgot the keyword enumerated. Well, there was even a little bit of a explanation, and one of the things that after learning about the Vim mode, I started to read about Xcode, and I stopped myself. I know I could probably spend half an hour to an hour just reading about Xcode and the tool. I've already mentioned that I'm on an old Mac, so it won't be the new stuff, and this Xcode is version 13.2, so it's a little dated, but I stopped myself because the goal of this series is just to keep focused on Swift, and even then I'm not doing a good job staying focused on that. But at some point I'll have to spend that time to understand the tool. But even just in the course of learning how to use Swift to program Wordle, I'm learning a lot about Xcode. One of the things, though, that I picked up is that if you hold Control, you can hold Control and highlight something, and when you click, so Control click, you can do things like jump to the definition. There it is up there. In the case of this function that's part of the collection array, you can jump to its definition, which let's see what it comes up with. I can't remember if this is the code or the documentation, but it's the actual code, and you can see the options here. It's actually this is the stuff below for the next function, which is min. We want to read about enumerated, which is this. Yeah, so there's a good amount of information here on enumerated, and I think, if I remember right, I'm going to close this. I thought I was able to hover over this and get some help. Let me click on quick help. I'm curious what that'll bring up. Wow, that's pretty slick. Again, I'm starting to like Xcode. It's not as fast as VS Code, but again, at work I have a really fast computer that's, I mean, it's tricked out. But this here is really helpful. And again, control click with quick help. So in order to prove that this works, we'll just rerun our tests. I'm going to click here. We'll just rerun all of them, even though the only test that really needs to be retested is the updateRow with the correct word craze. So here's the building. I'll have to, a lot of details to figure out in this whole thing. Oh, but look, it looks like the test succeeded. I missed the announcement of that, though. Yeah, test. Yeah, if I double click on this, yeah, you could see, I think I showed you this screen before, this log, and you can double click to get further details. Again, more things to learn about Xcode. But now that we have this, the next part of the algorithm is to remove the letter. So we have an array. We have the word that is the correct word. It's in the variable s. And if we do find a letter that is in the correct spot, what we can do is remove it. Now, I was thinking about maybe doing a diagram here so you can step through this. Why are we removing this letter from the array? The reason we're doing that is those letters that are in the correct position, they're obviously in the word. Those letters that are in the correct position don't need to be examined again when we're down here to see whether the word is in the whether the guess contains any letters that are in that word. It doesn't have to look at these correct words. We've already examined them. This is why we have, this is part of the nature of the to loop thing, because we are checking for two things. We're checking for green when the word is correct, and when the word is in the word, when the letter is in the word and it's in the correct place, or we're checking for whether the letter is just in anywhere in the word, and those two tests are different. This first test is more strict. It needs to match the index. But once we know that it's matched, we can remove it. Now, the way I wrote the algorithm is that we will remove the correct letter from the array. So how do we remove things from an array? I'm going to say remove. I think it's remove. So we can do this thing. And to do that, we say s.remove at, and then we're going to give it the index, which is idx1. Now, why idx1 and not I? It needs the method. It needs the specific index. And for string, you can't use an integer. You need to use String.Index. But we have an error here. So let's look at this error and try to. This is something I knew would happen, but this is something that occurs a lot in writing algorithms, writing instructions to tell the computer what to do. You end up tripping over yourself. So what is this message that it's telling me? We cannot use mutating member value s. S is a let constant. So right away, it's interesting. What we've learned is that these parameters that we pass into functions, they cannot be changed. They cannot be mutated. And because of that, we can't just do what we're thinking of doing. As a quick aside, we could potentially work around it. So here, I'm going to click on functions and just search here on, and this is something I'll put here into this. We just searched the documentation for inout parameters, and right. It says here right away, function parameters are constants by default. So in Swift, you can't edit these. To change the value of a function parameter from within the body is a compile time error. But you can declare something as an inout parameter. So that's done with this. So I'm going to try that, and I'm going to sit with it. This isn't in the code that I wrote, but yeah, inout right before the. No, maybe I think I better put it here, right before the type. Now we can remove this letter, and I'm going to sit with this because I didn't do this in the final implementation. Well, let's try to run the test and see what's happening. If the test is still valid, we're going to just rerun this one. And in fact, yeah, we're just going to click here the convenience method. The convenience, right on the UI, we can do this test. Oh, wow, it worked. Okay. I'm surprised. That worked. What this means is for our test, which is crabs, checking against the correct word, which is craze, these letters that are green, C, R, and A, will not be in the array anymore when this for loop is finished. So let's just run that through the debugger and confirm that. I'm going to go I guess I'll put it run right here. We're just going to run this test. Let's see if this stops in the debugger. Oh, jeepers, now I got a build failed. Hang on. Oh, wait a minute. It didn't pass. I was fooled. There's this compile time error right here. It says cannot pass immutable value as an input argument. Literals are not mutable. So this is a language thing. If I want to pass in a inout variable, I will need to have this be allocated memory. It can't just be a literal. And by allocated memory, I mean this var. Let's call it CW. It's going to be something like this. I'm pretty sure. Let's see what the compiler says when it catches up to this edit. Now it says passing value of type string to an input-output parameter requires an explicit ampersand. So already I'm not happy with this change, but I'm going to keep going. Let's see what the compiler says now. That looks fine to the compiler. So I'm going to now run the test, which was here. I just clicked on this little button here, which is the same thing as clicking on this one here. The build succeeded, and let's see what it does. It's running it. So it got all the way to the end of the for loop, this one anyway, and now we can take a look at the state of the algorithm. Let's wait for the debugger to catch up, which is this part here. What we're going to do when we get there is we're going to see just what exactly is in the letter S. And there it is. We see that it is string guts. Oh my goodness. String guts. But the string itself is RAZE because we just removed the letter C. And this variable C is the character that we're doing a test on, which is the letter C. So it looks like we're at the bottom of the for loop, but we're still in the iteration. So I'm going to keep this going by clicking on continue. Now, interesting. This thing says raise, and I am a little confused because even though it says 1 here, IDX, oh, you know what? I don't think IDX should be a let. No, but it's okay because it's the first. We're in a block here, this block, and this block can define a constant let, which is fine. And I am paying attention to when I'm here in the debug mode that hovering over these things does show their value, although it doesn't seem to be showing it for IDX. does show it for I. But I expected this to be AZE, but I'm going to keep going. This is again live. I did not do this. I went a different way. So I'm going to click through to continue. Once again, I is 2. I bet IDX is guess letters. Well, I'd really be interested to know what IDX is. I'm going to click on IDX1. Print IDX1. It's not in the scope of where I'm at. Makes sense because I'm not in this function. So I'm going to go here. Set a breakpoint there. I'm going to continue. We're at I equal 2, which would have gotten us through the letters. It would have gotten us through C, R, and A. So I'm going to click continue. Now we're in IDX here, and here's IDX at last. And okay, IDX, it's thanks Apple, but a string.index is not an integer. It's just it's a way to index into a existing string. Really, I think the best way to do it would be to say s.idx1 print s.idx1. Yeah, so we're on Z, which is 3. That makes sense. 0, 1, 2, 3. That's the 4th letter. So we're doing comparisons now. And S, the thing that's bothering me is that it says here S should remove these things at this IDX. But now I'm wondering if maybe I should have been using the integer. Yeah, this isn't looking the way I want it to look, but I'm gonna disable these and finish it. Okay, so the program crashed. It's saying, hey, your string index is out of bounds. I is 4. S is raise. And I already know what the issue is, and it's a somewhat subtle. In the let's put it in here. If we do, and this is maybe we'll end here without a single commit, but anyway, var s equal string raise. If I then make an index by saying var idx1 equal string.index utf. I thought this thing was going to do some completion for me. utxf offset, and I make it 4 in S. If I do s.idx1, we get the fatal error. String index is out of bounds. What is the 4th element in RAZE? It turns out there is no 4th element. The 4th element, the one that's indexed with the number 4, is actually the 5th element. Now, when this thing happens in the REPL, execution interrupted, I'm not able to get out of that. I have to quit and start it over again. But but simply put, R is index 0, A is index 1, Z is index 2, and E is index 3. But here I am trying to do a string index with number 4 here, and that's gonna fall off the string, and that's what this is saying. It's like, hey, you're trying to do a comparison with the 4th thing, but yeah, not allowed. And the whole time, this thing, AZE, it never changed. So clearly something is broken. And around this time, if this is like my day job, I sometimes just get up and walk around, think about what it is that I've done. But I'm just going to proceed and make a quick, here, look at that thing. We'll make a quick change here. What we'll do is, I have a theory that maybe I need to make the index be just the letter. So I put I here. Let's see what the compiler says to that. Yeah. Okay, this is also not a good solution. This is saying, hey, you can't use an I here. We need to have a string index. So I was right that you need a string index there. So I'll just undo this change. But we still have this problem, and I'll let you think about it for a moment as I stop the execution of this program with the stop. What's happening is, when we're here removing the matching correct letter, we're still in the loop. That's all that it is. We're still in the loop, and because we're still in the loop, removing this, making it smaller, has consequences, and in this case, our consequence was a fatal one. So when I ran into this the first time, I said, okay, what we can do is just keep track of the ones that are correct. We'll make an array, and we'll make an array of indices, and then once we have that array, we can then use that array outside of the loop and remove the letters that are correct. But as I'm doing this live with you here, I'm thinking that one way we can also do it is just to make a whole other array, again using another array, and just put here something like this. Now, what this is doing is it's fulfilling the design here. See, it says here, using array of correct letters, possibly modified by the above. What is the result of this loop? It finds all the letters that are in the correct position, and it removes those letters. So the result is, when we're in the second loop, what we have is an array of remaining letters. These are letters that we know are not in the correct position, or that the guess did not have letters that were in the correct position. I wish it could be a little more bearable to go through this logic, but you could see how this is primarily a exercise of the mind. As I verbalize this, I'm realizing I'm tripping over my own words to describe what I want to do. And in the end, what we're trying to do is just tell the computer to do it. So we have to keep ourselves sharp. Don't worry that you maybe can't necessarily describe it verbally, but maybe work hard to do a diagram, but work even harder to be able to express it in computer code. That's what we're doing as programmers. So this is different from what I did before. We're going to make an array of remaining letters, and it's going to be an array of character. I think that's all we need. And we're going to initialize it to be empty. And that should be enough. Cannot find remaining letters. Oh. Okay. So I'm going to run the test again. And yeah, I've disabled the breakpoints. So let's see what this test run does. And if this works, then we'll call it quits. Oh no, I have an error still. Look at that. Oh, I hope you can spot the error. I'm going to give you 10 seconds to spot the error. I'm still removing the letters. When I put this change in, it was a substitute of this work here. So I'm going to get rid of it. I'm going to try running it again. And it bothers me that I have these breakpoints, but no, it failed because of the. I'm going to try it again. Let's see this number here. Testing. Yeah, it worked. It worked. That test worked. And it means that crabs, when the correct word is there, is converted to this. But now when I look here at the test, I see here all of these changes. I did that because we were doing inout and all that stuff. But now we realize we don't need that. We're editing a array that was a constant. We said, okay, you don't have to be a constant. You can be an inout parameter. But now we're not modifying that string anymore. So we don't need that. And to fix that, we'll just get rid of inout. And I'll put that up here. Put craze back in here. And let's see what happens if I run this again. Just don't understand this number. That it's what is that number? All right, it passed. It passed, and we removed the inout parameter. And I don't know about you, but this looks reasonable to me. We have one whole other half to go, but we'll do that tomorrow. Let's get rid of these comments. And look at our changes. This. Instead of modifying string array, okay, everybody. That's it for tonight. We're gonna go and try this again tomorrow. We're gonna try to complete this second loop using an array of correct letters. What we're gonna do is just check whether the remaining letters are false, in the correct spot false, whether they're in the word. And there's going to be an easy mechanism to do that, but we'll cover that tomorrow. So we'll catch everybody then.